Hello, and welcome to Synoptic's Weather API tutorial. The Synoptic Weather API provides access to high-quality, real-time weather observations from thousands of stations. The examples covered here provide different ways of querying station data, whether you need real-time values, historical records, aggregated summaries, or historical context. In this video, we'll show example queries for how to access data in a variety of ways. Let's get started. To get started with Synoptic's Weather API, we need to understand the query structure for our API. A Synoptic API request is just an HTTP URL with the service endpoint and a set of parameters appended using ampersand. Below is an example query using latest, which grabs the latest observation from a station. In this query, the URL shown, up until the question mark, is the endpoint that tells the API which query or service you're calling. In this case, latest. The service being used will always come before that question mark and at the end of this base URL, which you'll see for all of the queries in this example. Next, we see some parameters for our query, starting with stid equals KSLC. This is a station selection parameter, specifying that we want data for the KSLC station, Salt Lake City International Airport. And token equals your token is just your API token required to authenticate the request. That will also be a part of every query shown in the video and for all the queries you conduct on the Synoptic Weather API. Every service you use will follow the same pattern. That base URL plus the service followed by a question mark, then parameter equals value, and then all of those will be separated by ampersands. Once you understand this structure, you can add optional parameters depending on the service you're calling. Once you enter a query, you will be met with the default output for our Weather API, JSON. For the purpose of this example tutorial, we'll just be looking at JSON outputs, but Synoptic also provides XML and CSV outputs as well for specific queries. For JSON, the output will be as follows. Summary will provide report request status, response messages, and timing information. Station will contain station level information and data, including metadata such as location and elevation, along with the important observational values that we're querying the API for. Units will define the measurement units used for each variable in the response. Quality control will report whether any observations were flagged by the Synoptic quality control checks. And with all of those in mind, we've gone over the basics for querying the API. Now we can go and make some queries. Let's start with the latest query. Latest returns the most recent observation from a station or set of stations. Here's an example query for latest that we can take a closer look at. This query follows the convention we found previously, that base Weather API URL followed by the service being used. In this case, latest. Next, stid equals WBB selects the station to be used for the query. Vars equals airtemp selects the weather variable to get the most recent value for, in this case, air temperature. And your token is just the user API token, but you'll notice here that it isn't coming at the end of the query, but rather in the middle of our URL. A good example of the fact that in the Synoptic Weather API, there's no specific ordering required for parameters after that base URL. Next, units equals English ensures Fahrenheit is used, and ob time zone equals local ensures the observation time returned by the query is displayed using the local time zone of the station. In this case, WBB or William Browning Building will have a local time zone of mountain time returned. This query fetches the most recent air temperature reading from the station WBB at the time of the recording. Here's an example of JSON output from the query. When we make a latest query for a station like WBB, the API returns a JSON object containing the data of our query, but also some metadata for the station such as ID, station ID, name, and much more, including an overview of the period of record, which is simply how long the station has been recording data. Here we can see WBB has a period of recording dating back to January 1st, 1997, up until today. The value to focus on for this JSON output is observations, which is the output of our query for the most recent air temperature reading for station WBB, which came in at 40.48 degrees Fahrenheit on 12:15 p.m., January 26, 2026, which was the time I entered the query just in Mountain Time. So, next we'll take a look at time series. Okay, so moving to time series returns a sequence of observations over a defined time period for a station or set of stations. This is ideal for tracking trends, charting variables, or analyzing patterns over time. Here we can see an example query for time series, which follows the same format as the previous latest query, except time series is being used as the service rather than latest, and there are a few new parameters unique to queries which require data over a period of time, which are start and end. So, as we look at this query, we can see we're fetching air temperature readings from Salt Lake City International Airport, or KSLC. We can see that from the previously used STID, but this time it's using KSLC rather than WBB. And here we have the start parameter, which is given a date. Here that date is January 2nd, 2015 to January 3rd, 2015. So we're pulling historical data from the station KSLC's record. Again, we use units equals English to return the air temperature values from the query in Fahrenheit, and ob time zone equals local will return the time values in the output in local time for the return timestamps in the time series. So after doing this query, the API will return a JSON object with observations. This is the part of the response with the data measurements we're after. Date_time contains an array of timestamps for each observation in the time period, and airTempSet_1 contains the corresponding air temperature values. Each index in the date time will match the value at the same index in airTempSet1, making time series requests ideal when you need a full sequence of observations over a defined period rather than just a single snapshot. Next, let's take a look at nearest time. Next, we have nearest time. Nearest time returns the observation closest to the time you request. This is useful when you need a snapshot at a specific moment for a station rather than a full series of values. In this example query, we asked the Synoptic Weather API to return the air temperature observation closest to a specific moment in time at a given station. In the example query shown, the station is KSLC, as listed under STID. There is also a new parameter, @time, which indicates the time we want the observation to be nearest to. In this case, January 2nd, 2015 at 6 p.m. The within parameter being set to 60 indicates we only want observations within 60 minutes before that target time. This JSON output shows us the air temperature at KSLC closest to January 2nd, 2015, 1800 UTC, which is 21.02 degrees Fahrenheit at 11 a.m. local time. The JSON also provides metadata about the station, units of measurement, and quality control information. Nearest time requests are ideal when you need one precise observation instead of a series of data points. Moving along with precipitation. Precipitation queries return derived precipitation totals or interval accumulations for a requested time period and set of stations. This is especially useful for analyzing rainfall patterns, daily totals, or tracking storm events over time. Here we have an example query which follows the basic Synoptic API query format, with STID being set to the station we require, in this case WBB or William Browning Building. But now, similar to the time series query, we have a start parameter which is set to January 1st, 2017 at 12 a.m., and an end parameter set to January 2nd at 11:59 p.m. We also see the parameter pmode equals intervals, which returns the accumulated precipitation for the interval specified in the intervals parameter. Here we have made it so we get accumulated precipitation values for each day within the period, but this value could also be set to hour, week, month, or even year. We could also set pmode to totals to return total precipitation between the start and end date, and last, which returns accumulated precipitation intervals based on end date. Upon execution of the query, The API fetches daily precipitation totals for the University of Utah's William Browning Building Station for January 2nd to January 3rd, 2017, returning timestamps and precipitation totals. Here we see the JSON output shows the daily precipitation at WBB during the period was 0 inches total precipitation on January 1st, 2017, and on January 2nd, 2017, total precipitation was 0.17 inches total. Beyond just the observations for precipitation totals in the period, the JSON provides the metadata, including first and last report times, and the number of sub-interval observations used to calculate the total precipitation for each day. Precipitation requests are ideal when you need summarized rainfall data over a period, making it easy to track trends, create charts, or analyze patterns in precipitation over time. So, moving to statistics. The statistics service returns summarized observations for a defined time period, specifically the minimum, maximum, and average of measurements within the specified period. This service applies Synoptic's advanced quality control as well as data aggregation. Statistics is ideal when you need an overview or aggregation of conditions over a day, week, month, or custom period rather than individual observations or manual calculations. In this example query, we asked the Synoptic Weather API to return daily air temperature statistics for the KSLC station from January 1st to January 3rd, 2025. We can see that the query uses the same parameters we used previously for time series and precipitation, start and end, to define the period we want to take a closer look at. The unique period parameter for this statistics query is simply the time period represented by return statistics. For example, the day value here means that the query will return daily statistics for January 1st, 2nd, and 3rd, 2025. Moving on to the output of our query, the JSON shown displays our output in the statistics section. Let's take a look at the data we found. So first, on January 1st, 2025, we can see that the minimum temperature for station KSLC was 26.06 degrees Fahrenheit. The maximum temperature for the station was 42.98 degrees Fahrenheit on January 1st, and the average temperature for that day for that station was 32.27 degrees Fahrenheit. These aggregated values are provided for January 2nd and January 3rd as well. Statistics requests are ideal when you need a compact overview of trends or extreme values over a specified period rather than a full time series. Alright, now taking a look at percentile queries. The percentile service returns percentile distributions for selected variables over a defined time period. Percentiles describes how extreme a measurement is relative to the historical distribution. Let's take a look at a Synoptic Weather API percentiles query, which follows the same format as our general API queries with the unique parameter of percentiles. In this example query, we asked the Synoptic Weather API to return daily 1st, 5th, and 10th percentile air temperature data at the KSLC station for the month of January 2025 in local time and Fahrenheit. The percentile parameter is set to 1, 5, and 10 and can be anywhere from 0 to 100. The JSON output now displays percentiles for air temperature at KLSC for the month of January 2025 for the indicated 1st, 5th, and 10th percentiles specified by our query. These values indicate that 1% of observed temperatures were below 17.06 degrees Fahrenheit, 5% were below 24.98 degrees Fahrenheit, and 10% were below 30.02 degrees Fahrenheit for KSLC's historic record. Synoptic's percentile service is ideal when you want to understand extreme or rare conditions without examining every observation individually. They complement statistics requests by showing where values fall in the historical distribution rather than just minimum, maximum, or average values. Finally, we have metadata queries. Metadata queries return detailed information about one or more stations, including location, elevation, operational status, sensor history, and available variables. It's useful when you need to explore station characteristics or filter stations by features such as variables, time zones, or historical sighting details. In this example query, we asked the Synoptic Weather API to return metadata for the KSLC station, Salt Lake City International Airport. We see some new parameters here, such as complete, which can be used for all API queries, and simply indicates if the complete metadata for the station will be returned. 0 is the default, which only returns the most common metadata values, but 1 indicates that you will receive the complete metadata for a station. Sensor vars indicates if the station sensor information will be returned with the 1 value to activate. And finally, the last new parameter we see here, obrange, is used to return metadata in a specified period defined with start and end times. In this JSON response, we can clearly see granular data for our chosen station KSLC. Metadata queries like the one shown give detailed identification information such as the station ID, full name, coordinates, and much more. The response includes a full list of all variables available for a station and the period of record during which it has been active. Metadata requests are ideal when you need context about the station itself, the who, what, where, and when behind your measurements. This information is essential for validating and interpreting the data returned by other Synoptic Weather API services. The examples we've covered highlight just a portion of what's possible with the Synoptic Weather API. Services like time series, statistics, percentiles, and precipitation all make it easy to move beyond individual observations and understand how weather conditions evolve over time, how extreme values compare to historical norms, and what patterns emerge across days, months, or years. These tools give you the flexibility to analyze weather at the level of detail you need. Whether you're supporting research, operations, or planning decisions, Synoptic's core API services provide a powerful foundation for turning real-time and historical weather observations into meaningful insights. I encourage you to explore our Weather API on Synoptic's website to start making queries of your own, and thanks for watching.